We've got more 6.4 today. We're going to be graphing tangent, cotangent, secant, and cosecant. I have written out their shorthand, tan, cotan, SEC of theta, CSC of theta, right underneath there. But we're going to start with tangent, and I've got a big chart started. Got an input value that's a radian measure. That's a place on the unit circle, 0 or pi over 6 or pi over 4. And then tangent considers the x and the y value. So let's look again at what tangent measures. So if we have a circle and we have an angle, so theta right here, tangent measures opposite over adjacent. And so it measures y over x. Tangent of theta equals the y value over the x value. So we're going to fill this in this chart and then graph what the tangent function looks like. It does not look like sine or cosine. It's got a squiggle in it, but it's vastly different. In order to graph tangent, we are actually going to start on our unit circle with negative pi over 2. So when I graph this, I'm going to want to graph, I'll do tangent on a big graph here. I'm going to say that this is negative pi over 4, this is negative pi over 2, positive pi over 4, positive pi over 2. So what I'm going to do in my unit circle is I'm going to, from 0, go negative pi over 2, and I'm going to start here. So this is a circle, but when I unroll it like a fruit roll-up, negative pi over 2 is right here on the xy axis. This is negative pi over 4. This is 0. This is pi over 4, and this is pi over 2. So when I unroll it, these are the values I'm going to get. So let's look. I told you I was going to start at negative pi over 2 and do negative pi over 4, 0, this is x is 0, positive pi over 4, and pi over 2. So I'm going to go from negative to positive, and that's halfway around the unit circle, from here to here. Okay, so looking at what all these values are, because tangent considers x and y, I'm going to start here, and I'm going to just write in the x value and the y value. 0 and negative 1, 0 and negative 1. Tangent is equal to y over x. So that's equal to negative 1 over 0. So what happens with negative? All right, coming back to you. Tangent, since it's y over x, it is actually a rational function. It is a fraction. And wherever x is 0, x is in the denominator, wherever x is 0, we have a vertical asymptote. That is the definition that our word wall person made for us, so thank you for that. The x value that makes the denominator of a simplified rational function 0. So at negative pi over 2, we actually have an asymptote that's vertical. That means that negative pi over 2 is not in the domain for tangent. And that's important for our domain. We'll look at that at the end of this. What happens at negative pi over 4? So I want to go back to, and at negative pi over 4 is right here. This is a 0, and I go negative pi over 4 and stop here. I've got the same x and y value except for y is negative. So the square root of 2 over 2 and negative square root of 2 over 2. So what does that mean for tangent? It means the square root of 2 over 2 over negative square root of 2 over 2. Just did that backwards. Doesn't actually matter, but the numerator is the negative one. So there you go. That's me correcting it. And so I have the same number on the top and the bottom. That makes 1. This makes it negative 1. And now I have a point. This is the input value, negative pi over 4. That's why I've got input up here and underlined. This makes a point, negative pi over 4. and the output is -1. This is x equals -pi/2 asymptote. All right, at 0, I'm here at 0. I have an x of 1 and a y of 0. X of 1, y of 0. I put y over x, and I have 0 over 1. 0 over 1 is allowed. Therefore, I have a point. That is 0, 0. I go to pi/4. That's up here. Here it is. It has the same x and y value. When I make a fraction out of it, y over x, I get 1. The input value is here, pi/4. The output value is here, it's at 1. These are similar, just opposite signs. And at pi/2, I'm up at the top of the circle, the northmost point, and I have 0 for x and 1 for y. That's 1 over 0. That is also undefined. It's an asymptote, x equals pi/2. So I'm going to draw that in. All right, so I've got two asymptotes, and I'm going to mark off, here's 1 and here's -1, and fill in from there. So I've got 3 points I can draw in. -pi/4, -1. -pi/4, -1 is there. This middle point is 0, 0, and pi/4 is pi/4, 1. Now this is not a straight line. It can't run into my asymptote. It does something else. So now we're going to use a calculator because this is already a 7-minute video. So I'm going to pause. I'm going to write down some numbers, and then we will fill in the rest of the chart. So I've added 4 points. So I'm going to pull up my calculator, and we're going to plug these in and let the calculator figure them out. So I've got a calculator. I'm going to make it a little bit smaller. I can see my chart. Here we go. Maybe a touch bigger. Okay, so there we go. Now, I chose these points because they're in the middle between these. So, for example, -pi/4. -pi, whoops, clear. -pi divided by 4 is about -0.7. So this is the same thing as -0.7 as far as numbers go. Just like pi is 3.14, the other values have actual number values. So I picked values that are around that. So -1.5 is somewhere here close to -pi/2. So let's look at that too. -pi divided by 2. So -1.57. So this is really close to pi/2, which I can't plug in because it gives me 0 in the denominator. So I can get really close to it. That's what an asymptote does. It's a border, but I cannot plug in -pi/2. Let's see what happens. Tangent of -pi divided by 2. And it won't let us because it's not in, interesting, it's not in the function domain. Okay, so clear that out. Let's try these values that I've got in my chart. Tangent of -1.5, enter. So -14. This is tangent of -1.5 equals -14. Tangent of -0.5. So tangent -0.5, -0.54, and then these two are the same values but positive. 0.5 and tangent of 1.5 is approximately, I probably should have put that for all of these, 14. So approximately, because I rounded them. So here's what the graph looks like. It goes at about -0.5 it's negative 1/2. And at 0.5, it's positive 1/2. But when we get really close to negative pi over 2, which is negative 1.57, when we get here, it goes all the way down to 14, which we're just going to estimate to be somewhere there. And this is positive 14. So over here, I've got positive 14. So tangent actually looks like this. And this asymptote continues down. My tangent graph never crosses it. It's an asymptote. It's like a border. And the interesting thing about tangent is that when I go around the other half of the circle, it repeats. So the exact same thing happens again. It is periodic, just like sine and cosine. The same pattern repeats, except it repeats in a period that is this far. So this is one period, and the period is equal to pi, not 2 pi for tangent, also for cotangent. So what happens is every pi over 2, x equals k times pi over 2 is an asymptote. Every time we go around the unit circle, and let's see the unit circle, every time we're here or here. If we start here and go around, asymptote, 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 asymptote. Every time we go halfway around, actually pi, sorry, this way all the way around is pi. Halfway around the circle is pi. We get another asymptote. So it looks like this. The pi over 2, we have 3 pi over 4, and then we have pi. And then we have 5 pi over 4. I'm going to squeeze this in, and then we have 3 pi over 2. We have the same shape. Again, there will be an asymptote here. And my light just went out. Okay, so I drew the other asymptote in. It's going to go through 0 right there at pi. And it comes down like this, and then it follows the other asymptote. So it will repeat, and there'll be another one that will squiggle here. Let's look it out on your graph so that you can believe me. If we go to y equals, and then we type in simply, there's no way to put theta in. See how it says theta on here? So we mean tangent of theta, but it types in x, and that's okay. It just means there's a variable. We're plugging it in. And when we graph that, let me make sure I'm in the right mode. I am. I actually want to change my window. No, I lie. I don't. Graph. Ooh, maybe I do. Window, zoom 6. There we go. So tangent goes through 0, 0. That's going to help you be able to tell it apart from cotangent. So tangent goes through the origin, and it repeats over and over again. This vertical line that would be right here is at pi over 2. So the things that you have to remember are that tangent goes through 0, 0, and it has an asymptote at every pi over 2. If you put a k as 1, k is some integer. Or k is -1, you'd be at this one. Or k is 3, you'd be at this one, 3 pi over 2. So any integer value, there's an asymptote, and tangent repeats. So it looks like it has a wave to it, but it's a vertical wave. And because we're dividing by a very small number, we end up getting very large values. If you put in something like 1.56, you're going to get a really huge number. So just for fun, tangent of 1.56 is 92. It went from 14, so this was positive 14 for the positive 1.5, to 92 really quick. And then if we said tangent of 1.569, we get 556. So it is growing really fast as you get closer and closer to this pi over 2, which is 1.57. So this is tangent. It goes through 0, 0. It has asymptotes. Try to learn what it looks like because it's way easier than making this gigantic chart. Okay, we're going to graph cotangent in just a second. All of the trig functions except for sine and cosine have asymptotes because they are fractions. Cotangent means 1 over tangent. It is the multiplicative inverse or the reciprocal. So reciprocal of tangent, that's how you have to put it into graph it, is actually the reciprocal of tangent, and it's known as x over y. So I could make the same chart that I did before. I'm not going to right now. I'm going to show you the shortcuts to graph it, and you can use the same shortcuts when you think back to tangent. So looking at the unit circle, if it is x over y, the vertical asymptotes happen. Vertical asymptotes happen when what? They happen when y equals 0. So x equals, let's look, when y equals 0. When y equals 0. These are the values. Every pi, y is 0. So x equals 0 or x equals pi, otherwise known as x equals k pi. That means every integer times pi. 0 is this one. 1 for k is 1 pi. 2 pi, 3 pi, whatever k you put in, or even in reverse, negative 2 pi is going to be a vertical asymptote. So it looks like this, because I'm just going to graph it quickly. That means that if I just put in 0, and then I'm going to go to pi and 2 pi. This is 3 pi over 2 and pi over 2. This is negative pi over 2, negative pi, negative 3 pi over 2. From 0 to pi to 2 pi, every one of these is a vertical asymptote. And I'm graphing this one smaller, okay, just so I can squeeze in more repeats of it. So its period, put it in blue, period is pi. Every pi cotangent of theta repeats. Now the cool thing about tangent and cotangent is that they are opposites of each other. So if you look, I'm going to let you see it here, and we have to graph it differently. We have to graph it as a fraction. So second fraction, I'm going to put 1 on top, and then tangent of theta, which will print as x, on the bottom. And then if you notice, tangent looks like positive Saturday Night Fever, but cotangent looks like negative Saturday Night Fever. So it starts on the left-hand side and goes to the middle part, whatever number's in the middle, and then down. And I'm sure mine aren't wiggly enough. They probably should be more like that. So this arrow is trying to be the asymptote. But it actually goes to infinity as x approaches, let's say 2 pi. So if we're going this way, we're approaching 2 pi. We'll even say from the left, that means this way. Y is trying to be negative infinity. It's going down. And as x approaches 2 pi from the right, I would have another repeat here, drawn badly, but as it goes this way to 2 pi, it's going to positive infinity. Y is going to positive infinity. So tangent and cotangent look very similar, but they do cross through different points. This one has pi over 2, 0. That's what I think of as my starting point. And it has a period of pi, and it has x equals k pi as a vertical asymptote. Which means if this is a vertical asymptote, this means that the domain for cotangent is x is not equal to k pi. So it's every x except for one that's k pi. So that means negative pi, 0, pi, 2 pi, 3 pi, etc. All right, there's cotangent. Yay! I'm going to put secant and cosecant in a separate video just for a time in case you want to get up and stretch, do some jumping jacks or plank or get a snack or whatever you need to do. I'll see you in just a sec.